Hey folks, this is Jay from Chandler, Arizona. Let's talk about use cases in quantum computing today. I'm gonna talk 7 about them. This is not a full list, but this is what opened my eyes and made me passionate about quantum computing. Number one, I'm gonna talk about is the buzzword of this year is artificial intelligence and machine learning. The capability of calculating solutions to problems simultaneously, which quantum computers give as opposed to sequentially in a classical computer, is a huge advantage for artificial intelligence and machine learning. Organizations today are using AI and ML to discover new ways to automate or optimize tasks. In the future, if we combine it with quantum technology, quantum optimizers, quantum computers, uh, this process, this iteration around automating, identifying patterns, and optimizing solutions can be done in a parallel fashion with multiple options being analyzed at the same time so that uh, the processing time can go down and the solutions to certain very complex problems can be done faster. This is especially true when the data is huge and very, very complex. Number two is financial modeling. Today, as the markets, as in this flat world, as these markets are linked, the financial markets are linked to each other, the banks, the traditional banks, and other financial organizations who manage in investment behaviors and securities at times struggle to figure out what are the risks and how are the investment patterns changing, how are the financial economies are moving along with government regulations. What a quantum computer could do is it could basically uh, look at all data real time coming from global markets to figure out the trends of the investments, the securities, the regulations, to ensure that the risk to the financial organization and then the risk to the customer who is investing can be lowered over time. Number three is cybersecurity. Cybersecurity is already something which has been impacted tremendously by quantum computers, first generation quantum computers. Quantum cryptography can be easily broken. Current cryptographic algorithms can be easily broken by quantum computers. So there are first generation sensors, chips, which are already available, which are helping companies, especially financial companies and banks, to encrypt their data while in use, while in transit, and uh, and ensure that uh, the data doesn't leak out when a calculation is going on and things like that. Number four is route and traffic optimization. Air traffic control, supply chain logistics, especially after the global pandemic, we have seen how brittle they are. They are brittle because it is a very complex challenge in terms of figuring out weather patterns, in figuring out e-commerce patterns, in figuring out seasonalities of different countries, in figuring out country level issues like a war and things like that. To figure out all that data in real time is very hard. A quantum computer can gather all this data in real time and create at least 10 to 15 different routes and optimizations to pick the best route in parallel, which will help then optimize routes and traffic. Same for air traffic control. Number five is manufacturing. Manufacturing, not in terms of actually manufacturing the product, but also but in terms of understanding and prototyping new products to in the market uh, by running quicker tests in parallel and understanding how different components will interact with each other, the prototypes can be released faster with and tested faster, so that the cost of R&D itself can go down. Number 6 is drug and chemical research. This is, I think, one of the biggest advantages of quantum computers. A quantum computer can create better models and an understanding of how molecules and atoms interact with each other. Today, this is not possible in a lab. What you could do is at a molecular structural level figure out how they interact with each other uh, in a small product, in a big product, in a human body. And it would also help drug discovery folks research this on a computer rather than in an actual human being, that way reducing risk, that way reducing the cost of clinical trials, and giving foresight on what is the safety of a product, what is its impact on the environment, so on and so forth. Last but not least, with the advent of a lot of electronic vehicles and our phones and things like that, is batteries. Batteries is probably one of the highest used, lithium batteries especially, one of the highest used and researched market just now. Today, a quantum computer can actually tap into and understand the docking energy of a protein and how it works in a battery composition, which will then result into longevity of the batteries in EVs, in phones, and things like that. Similarly, it could also help chemical companies to figure out how to create batteries with different components, so that they are not only not dependent on a few metals for batteries. So that's it, folks. If you like this video, please like, share, and subscribe. And if you have any questions or suggestions, I'm more than happy to take comments. Thank you.